All right, so this section 4, we're going to spend today and tomorrow working on this law of cosines. You may remember this. It's been a while, but this red triangle is in quadrant 1 with a vertex on the origin and another vertex out here on the x-axis. This is called standard position. And in standard position, the third vertex is somewhere up here in quadrant 1. Okay? So the coordinates of A, x comma y, would be, this distance would be x, this distance would be y. This is a right angle. So if we solve for x and y, we can do cos c in the triangle on the left would equal x over b. And if you solve for x, b cos c would be x. That's the x coordinate of A. And sine c is y over b, so b sine c is y coordinate for A. Now what we're looking for is our ability to find out how long c is. We know little a, we know angle c, and we know little b, and we're trying to figure out the distance between point A and point B, which is side c. So the way we're going to derive this formula is we're going to use the distance formula. We haven't done distance formula in a while, but this is how we're going to derive law of cosines. And we're going to use the distance from A to B, so the coordinates are b cos c, b sine c, and A comma 0. So that's what I plugged in, b cos c minus A, quantity squared, and b sine c minus 0, quantity squared. When you square the binomial, you get b squared cos squared c, 2ab cos c, and plus a squared, not minus a squared. Over here, the 0 is gone, and you get b squared sine squared c. B squared cos squared c plus b squared sine squared c. I took the b squared sine squared c and put it next to b squared cos squared. And I put the minus 2ab cos c at the end. So I still have an a squared. What I'm going to do here is I'm going to group the first two terms like that. What do they have in common? B squared. B squared. So I'm going to factor out a b squared, and I'll be left with a cos squared c plus sine squared c, that are known as 1. So that parenthesis will be gone. We'll just have b squared plus a squared minus 2ab cos c. Now my OCD is not going to let me leave it like that. What am I going to write? A squared plus b squared minus 2ab cos c. That's your law of cosines. And it's law of cosines when you know the two sides of the angle in between. C, little c, that's the side that you're looking for. It's opposite the angle that you were given. And A and B are the sides you know. C is the angle you know. Now again, I try not to get too worked up over A's, B's, and C's because I just get confused, especially when there's no A's, B's, and C's. And I usually think about it like this. This is the side you want. It's equal to the side you know squared. Side squared plus side squared minus 2 side times the cosine of the angle you know. And you're going to see me refer to this generic versions more often than you're going to see me refer to the A's, B's, and C's version. You do whatever you want. I'm not trying to talk you out of memorizing 3 formulas. I'm just telling you, you've got to be able to do the law of cosines for sine equals sine. Correct. This version of law of cosines will only be working for sine angle sine. need more time to copy? Everybody good? This is what the book gives you for law of cosines. And I don't know why different books give different versions. Obviously, if you were trying to find C, you'd still have one more step to do, and that would be to square root both sides. So I'm never really sure why the book chooses to give this version. You're welcome to go with this version if you want. And here's the other two. B squared equals A squared plus C squared minus 2AC cos B. And A squared equals B squared plus C squared minus 2BC cos A. You can memorize all that. And put the right sides under radicals if you want. I don't care. It's totally up to you. But what I'm trying to suggest to you is not to use that formula and to try to stick with, these are the sides you know on the right hand side under the radical, and this is the angle you know. Try not to get too worked up over the order in which you put A and B in there, or the sides you know. It doesn't matter. Whatever side you want has to be opposite the angle that you know when you have a side equal side. For side, angle, all of these things, you can only make one triangle for this. If you're given a side, angle, side, it's not ambiguous. There's only one triangle. When is the only time, if I give you these pieces, that you might have an ambiguous situation? Angle, side. Think chord. Bad ace. Okay? That's what you got to think about. So all of these other situations, if you're coming up with two angles or two triangles, it's wrong. Now, some of you aren't listening to me right now. I'm just telling you that none of this is ambiguous. There's only one way to do this. All right? If we take the law of cosines and we continue on and we isolate an angle, in this case the only angle in the picture is C. We square both sides, we get to the book version. We bring the A squared and B squared to the left. And then we divide by negative 2AB. Now right here, we're going to take the top and the bottom, and we're going to multiply by negative 1 over negative 1. And when you do that, you're going to get positive A squared, positive B squared, and a negative C squared. And on the bottom, the negative cancels, which is good, 2AB. So angle C would be the cosine inverse of this mess. You're going to use this version of law of cosines when you have a side situation. If I give you three sides and you need an angle, you're going to use this version of law of cosines. Angle C is going to equal cos inverse of A squared plus B squared minus C squared over 2AB. If this angle is what you're looking for, the side square that you're subtracting is opposite the angle you're looking for. If this is the angle you want, these two doesn't matter which order. Those are not opposite the angle. The one you subtract, the side you subtract is opposite the angle you're looking for. And I'll give you a generic version of that. We have two versions of law of cosines. One for side, and one for side, angle, side. Okay? Side, angle, side for this one. Side, for this one. But you only use law of cosines under these circumstances. Anyone need more time to copy? Okay? So, in this example, don't get too, I drew an obtuse triangle. You do not need to draw it accurately unless you want to. I don't really care. So, but I will tell you, and I've been telling you this chapter, make your pictures bigger. Those of you who are making pictures that are 2 inches across, make them twice as big. you're making your pictures too small. You're spending, your pictures and your work are too little. You're going to be your worst enemy, your own worst enemy on this. Make your pictures bigger. This is 130 degrees. Two sides of the triangle have 3 and 7, the angle in between. So this is 3, this is 7. Find the length of the third side. We can call this x. If you want to label the triangle with vertices, you can, but they didn't give them to you. It's not necessary. What did they give you? Side, angle, side. That determines which version of law of cosines you should have. We're looking for x, so we should be doing law of cosines, the first one. Right? Caitlin, give me the plug-in on this.
3 squared plus 7 squared minus 2, 3, 7, and then
Cosine of 1/3. Now, that's the only work I need to see from you. Most of you have a calculator in which you can go from there to your answer. And I am perfectly fine with that. Make sure you're in degrees, and then you should be able to find the third side's measure. Yeah, did you already get this? What'd you get? 219, and we would be going with centimeters on that. Is anyone getting anything different than that? All I need. You can do this in one shot on your calculator if you figure it out. And again, this time, they're only asking you for the length of the third side, so it's really important as to how they ask the question. Okay? For this one, it's just what's the third side. So again, in the book, they give this cos c a squared plus b squared minus c squared over 2ab. Just remember, if this angle and the one that you're subtracting squared are opposite, this is more likely how I would handle it. I just think, okay, cos of whatever angle I'm looking for under side, 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 if this is the angle, this is adjacent, this is adjacent, this is opposite. So adjacent squared plus adjacent squared minus opposite squared. Over 2 adjacent, adjacent. The order for the adjacents doesn't matter. It's only that you're subtracting the opposite squared. So you can utilize either version of this. It doesn't matter to me.
So once you solve for the first angle, then you put the 2 law of sine.
We'll talk about that in a second. But yes, that's your question. Corey, you right back there?
Yeah.
Okay. So in this particular situation, side, 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 for alpha and beta, we're just going to plug them in. Allison, what would you plug in if we're going to find cos alpha, this one? Go ahead. 5 squared plus minus 12 squared. On the bottom, 2 times 10. These two right here, the 5 and the 10, are the ones that are adjacent to and make up alpha. So, Vitri, how about beta? 10, 12, and 5, and on the bottom, 10 and 12. Now, again, I'm less apt to write it like that and more apt to write it like this for theta and say cos inverse, open a parenthesis. Kevin, what should I put for theta? Yeah, for cos theta, we're going to do law of cosines for side, side, side.
5 squared
5 squared
plus squared.
minus
Minus 10 squared
10 squared over,
or 2 times 5 times 12.
okay? And again, if you do this correctly, that's all the work I need from you. Your next line should say theta equals, and then you tell me what theta equals. But here's where you need to be careful on your entering. When you do cos inverse, at least on my calculator, it's going to open this parenthesis for you. You need to make sure the top is in parentheses divided by the bottom in parentheses, and then close for the cosine. If you don't, you're going to screw it up. See if you can find out what theta is.
There's never going to be any.
I'm not familiar with the triangle. Well, no. This, not if you do it correctly, it won't be. What is it? 54.900. Everybody good with that? This is my opinion, and my opinion only. Law of cosines is harder than law of sines. It's a little bit more complicated. And we're not talking about calculus versus pre-algebra harder. Just a little bit more work, a little bit more complicated formula. I think law of sines is really easy formula. You plug and play, it's all good. In my opinion, I would never do 2 law of cosines in a single problem. So if we were asked to find all the missing parts of this, I would do law of cosines like we did right here. We got 54.900. Then I would do law of sines. Okay? I would do law of cosines first, then do law of sines. Now, you should make a note of this if that's what you're going to do. If you are doing law of cosines and then law of sines, always find in law of sines, find the smallest angle first when you do your law of sines. Because otherwise, your calculator is not going to give you an obtuse angle if there is an obtuse angle. Okay? Now, if you want to avoid even having to worry about it altogether, when you do law of cosines for a side, 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 always find the biggest angle first, and then the problem is solved. Right? How many obtuse angles can you have? 1. Law of sines will not give up an obtuse angle in an answer. Law of cosines will. So if you do law of cosines and you're doing an obtuse angle, it will come up based on what you do in your calculator. Law of sines will not. So in this problem, if you want to avoid all potential issues, which angle should we be finding first? You should be finding alpha first. So if you do cos inverse of this, see what you find out for alpha. Do cos inverse of alpha and see what that angle alpha turns out to be. When you do cos inverse of 5 squared plus 10 squared minus 12 squared over 2 times 5 times 10, what does that give you for alpha? 100.953 degrees. That's alpha. Okay. But watch what happens if we do law of sines after we do theta, and we do this wrong. So if I find alpha, and I say the sine of alpha over, I think it was 12, all right? Sine of alpha over 12 is going to equal the sine of 54.900 degrees over 10. And we solve for alpha, you're going to have 12 sine of 54.900 over 10. And you're going to do sine inverse of that. Alpha will be sine inverse of 12 sine 54.900 divided by 10. See what you get for alpha this time. 0.46. What kind of an angle is that? Acute. And it's not correct. Okay? We know, because we've already done alpha correctly, it's 100.953. We don't have the, nobody really has the ability, well, Corey might, but the rest of us mortals, we don't have the ability to know that alpha is supposed to be an obtuse angle. This is not an ambiguous problem. The reason why it became ambiguous is because when we did law of sines, we did it with an ASS situation. If you want to avoid that, find alpha first. Using law of cosine, all problems solved. Okay? So if you're doing law of cosine side, 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 always find the biggest angle first. Whether or not it's obtuse or not will happen automatically based on your work. If it's not obtuse, it's no big deal. If it's the biggest angle and it's still acute, the other two angles have to be acute as well. And then when you do law of sines, it will all be good. Law of sines, when you do sine inverse, can only give you a quadrant 1 or 4 angle. In a triangle, it has to be a quadrant 1. It doesn't know any better. The calculator, I mean. You need to know better. When you do law of cosines for side, 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 always find the biggest angle first. And then your problem will be solved. When you do law of sines after law of cosines, always find the smallest angle first. Okay, let me say that again. When you do law of cosines for side, 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 find the biggest angle first. When you do law of sines after a law of cosines, always find the smallest angle first, and you will not have any issues with finding the wrong measures. But you have to keep those two guidelines in check when you're going through those. Take a minute, see if you can find AD on your own. Big triangle first, find an angle, then shrink down. Whether you find angle B or angle C, it just doesn't matter. That's up to you. If you found angle C first, then you would be doing log cosine with the 7 and the 4 and angle C. We did angle B, it just doesn't matter. What matters to me is that it's crystal clear what your work is and what you're finding. Okay? This is the minimum. If you have more to show me, that's fine. A triangle has sides of 6, 12, and 15. Find the measure of the smallest angle. And then find the length of the median to the longest side. So in this particular problem, the longest side is 15. So that's the bottom. This will be our 6. This will be 12. Find the measures of the smallest angle. So let's call this triangle PQR. PQR. Which angle should I find? How come? How do you know this? It's opposite the smallest side, so it's got to be the smallest angle. Now, every year, I have people find P, then Q, then R, and they go, oh, yeah, look, R is the smallest. Circle it. You don't need to do that. In a triangle, smallest angle, opposite smallest side. Okay? So if we're going to find angle R, we're going to use law of cosines. Angle R is going to equal cos inverse of what? And you're going to do cos inverse of that mess. And then you can go straight to your answer with your calculator. But you need to plug it into your calculator to do that. So many of you just sit here, you don't do it in class, you don't do it on your homework in a lot of cases, you just copy the answers, and then you come to the test and you can't do it. And you can't understand why. You're good at everything you've been doing. Your test just sucked, Mr. Lockray. You suck too, by the way. Alright. But, try these problems in class. You'll figure out whether or not you can do them by the time you get to the test. What did angle R turn out to be? 22? 22.332 degrees. So 22.332 degrees, that's this angle. Now, find the length of the median to the longest side. I drew that in there. I'm going to call it M. If you're trying to find M, how do you do that? How are we going to find the length of M? Okay, now how am I going to find out how long that is? Law of cosines? Okay, what side angle side do you have? That's 22. But you're right, 15, 12, 22.332, and 15 would get you this side, which we already know. Now you've already said how you're going to do this, but you aren't aware of it yet. What isn't he seeing?
What median does.
And he said what it does, didn't he? So how is that going to help him?
Yeah.
So these pieces here
Yeah.
are 7.5s. So now you have side angle side, and M is going to equal what, Alex?
squared plus 7.5 squared minus 2 times 7.5
Times.
cosine 22.
Boy. So that's all you need to show me in order to verify what M is going to equal. If you have a calculator, what does it equal? What is it? How about a decimal, just for fun? 5.80. So that's M. That's R. Any questions on that? Okay, so to synthesize all this law, cosine, law, sine stuff from the last couple of days, it's all based on what you're given. If you're given side angle side or side side side, you're going to use law of cosine. Side 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 is the first law of cosines. Sorry, the second law of cosines, and side angle side is the first law of cosine. Side angle side is going to find the third side. Side 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 is going to find any one of the angles, hopefully the largest. That should be what you start with. For law of sines, for angle side angle, angle angle side, no problem. That's going to get your missing side. And for the bad ace case, the ambiguous case, you're going to still use law of sines, but the angle opposite the given side and the third side that you find, there may be multiple triangles, there may be no triangles. There may only be one. That's why it's ambiguous. But the only time you should worry about getting multiple triangles is if you have an SSA situation. If it's any of these, you can't have an ambiguous situation. So in order to avoid that, if you're doing law of cosines, find the biggest angle first. If you're doing the law of sines after a law of cosines, find the smallest angle first. And then you will avoid having that ambiguity of the calculator issue. Right? Any questions on this breakdown? So this is really tells you what you do based on what you're given. Side, angle, side, 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 angle, side, angle, 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 side, angle, side, side. What's the situations that are not shown up here? Yeah, and we can't do anything with that. Or angle, angle, we can't do those. So more specifically, right triangles. And if it's a right triangle, you should not be using any of this. If it's a right triangle, you should be using right triangle trig. Okay, just a reminder, Pythagorean triples sometimes are useful. And the 6 that I highlighted are the most common for us. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. Those 4 are pretty common. But 9, 40, 41, 11, 60, 61, sometimes they appear. The rest of them I just put up more as a novelty. Mitch is going to memorize them, but the rest of us, the 36, 77, 85, we're probably going to miss that one. The 33, 544, 545 triangle. I got one of those in my backyard. Right? So today's just a short assignment, 1 to 7 odds and 15 to 7 bonus. Don't take it so personal. Short meaning the length of the assignment. Nothing to talk about your stuff. Dude. Alright, On 15 and 17, I think those are the two applications. The picture in the book would be a micro picture. I'll tell you what, the plain one, draw the picture all the way across your paper. Because you've got to find a triangle that works for you in there, and there are 3 triangles that you have to deal with. So bigger picture will be much better for you in that situation.